All right. Hello, good morning, and good afternoon to those joining us from other time zones. Welcome to today's webinar, Apache Kylin 101, Getting Sub-Second Analytics on Massive Datasets. My name is Tyler Wishnoff. I'm a marketing manager for Kyligence and your moderator for today's session. I'm joined by Kaige Liu, Kyligence's Senior Solutions Architect. Kaige brings with him extensive experience in the big data analytics space, as well as virtualization and cloud computing expertise from his time at IBM, serving on their OpenStack and Bluemix teams. But what brings him here today is to share with all of us his passion for the Apache Kylin project, which he serves as a committer for. Kaige will walk us through the project, what it is, where it can help, and even provide a full demo to see it in action. Now, before we begin, a few minor housekeeping items. Today's presentation should run for about 30 to 45 minutes, with 15 minutes reserved at the end for Q&A. Please reserve all questions for the Q&A section. You may communicate those questions at any time via the Q&A function, which can be toggled with the Q&A symbol at the bottom of your screen. Lastly, this webinar is also being recorded, and you will have access to it a few days following the session. With that said, I'll pass things over to Kaige to get us started. Kaige, the floor is yours.
Thank you, Tyler. Good morning and good afternoon, everyone. Thank you for joining this webinar. Today, I'm going to introduce an OLAP engine of big data, Apache Kylin, which is a top-level project in Apache Foundation. Okay, here are some topics we are going to talk about. First of all, I want to give a quick overview about OLAP. Understanding basic OLAP concept help us understand Apache Kylin better. And then I'm going to introduce Apache Kylin, including some key features, architecture, basic usages, etc. After that, I will give a demo on how to use Apache Kylin to build an OLAP cube with big data technology. And let's get started. Let's take a look at some common questions decision makers are usually interested in. Assume Theodore owns a supermarket chain. You work for him as a data analyst. Here are some questions he probably will ask you. What are our top 5 best-selling products in each state or city? People in different places usually have different consumption habits. Knowing popular products in different places can help them build proper supply chain. Which product should be put together? I believe you all know the best couple story, beer and diapers. By analyzing which products are always sold together, we can put them closer to increase sales. Do you have enough toilet paper prepared for coronavirus? Can OLAP help us answer this? Yes, I'm not kidding. We can analyze average toilet paper consumption per family to know if you have enough toilet paper for maybe next 2 months. Who owns this supermarket? No, you forgot your boss name? Just kidding. Actually, this is not a typical problem OLAP can solve. So what is OLAP? How can it help us on those questions? The problems listed above seems to be relatively simple. You may think, I can get this problem through a spreadsheet. Why we use OLAP? That's right. In order to explain the use of OLAP later, I used some simple scenarios here. For those scenarios, you can use a simple spreadsheet or write some simple queries to solve. Then if the problem expanded into many different dimensions, such as adding a brand, color, packaging type of the product, or the manufacturer, origin, supplier, etc. To analyze those dimensions together, the complexity will increase greatly. Or maybe it's not just you want to analyze the profit. Maybe you want to calculate it weighted profit according to different sales channels, or maybe analyze the growth rate or retention rate of customers brought by a certain promotion activity. If you want to quickly and easily analyze similar business scenarios, then we need you to use OLAP. OLAP is an abbreviation for online analytical processing. It's a technology behind business intelligence and applications. And OLAP is designed for analysis-oriented, and it's a powerful technology for data discovery, including capabilities for limitless reporting viewing, complex analytical calculations, and predictive what-if scenarios planning. But OLAP is not suitable for all scenarios. If your scenario requires, for example, frequent updates or deletions for historical data, most of them are detailed data queries, or there are only a few aggregate queries in your scenarios. OLAP is not a good choice for you. OLAP usually use a multi-dimensional data structure known as OLAP cube to store consolidated information. Let's check this example. There are 3 points of view to measure the cells: location, date, and product. In this case, we have 3 dimensions, and so that you can imagine as a cube. That's why we call it cube. You can put the more dimensions in this cube, but it will be very hard to draw it in PowerPoint. So I choose 3 dimensions as illustration. But and then we put the sales number in each small dice. So our data will be stored in this cube. Now, how can we use this OLAP cube to answer those questions? For example, how many beers are sold in Los Angeles in June? So in these questions, we know the location is Los Angeles, date is June, and product is beer. We can use these 3 conditions to search from this cube. And then we can find the result easily. It's 90. That's a simple example for how OLAP cube can answer some simple questions. You may already notice that there are 2 key elements when we are talking about OLAP cube: measures and dimensions. Most of us are very familiar with tables. Actually, it's very easy to map tables to a cube. Let's see how we can do that. First, we need to identify measures and dimensions in those tables. Measures contains numeric value you can measure. They are usually some values you want to calculate and use to indicate how things look like. For example, revenue, sales amount, KPI, etc. Usually, measures reside in the fact table. Dimensions give context around the measure to help you understand the meaning of those measures. When you look at the measure in different point of view, measures will have different meanings. For example, we can measure profits by month or by city. By calculating measures from different dimensions, you can know your business from different angles. In this example, you can choose those columns from lookup tables as dimensions based on angles you want to calculate your measures. All right, after identifying measures and the dimensions from those tables, we can use them to construct a cube. Let's check the cube again. The location, date, and the product, they are dimensions. And the sales number stored in the cubes are measures. All right, let's look at the question again. How we map the dimensions and the measures into business scenarios. In this question, the words in blue are measures. We want to know the total sales number as a measure. And those dimensions are in green: Los Angeles, beer, and June. Those 3 dimensions give us a context of the measure. Now, we know how to extract dimensions and measures from tables and construct cube with them. And we are able to answer these questions with the cube we have. Let me introduce more basic operations in OLAP cubes. With these operations, we can get more insights from the cubes. Common operations on cubes are rollup, drill down, slice, dice, and pivot. Due to the limited time, I'm not going to introduce them all. Just a pickup, rollup, and drill down as an example. Rollup. Rollup is used when you want to get a measure from detail level to a general level. For example, we already have measures in this cube for April, May, and June, but we want to know the total sales number in the whole quarter. Then we can do a rollup like this to get measures in Q2. And drill down. Drill down is used when you want to dip into a fine-grained level. The same example, we already have the sales number for each month, but we still need to know how it look like for each week. Then we can do a drill down on this cube to get measures for each week. Roll-up and drill-down are widely used when there are hierarchies in the business model. In this example, we have a data hierarchy, year, quarter, month, week. Other common hierarchies are nation, state, city, county, or maybe product categories. All right, let's take a look at the traditional OLAP tools we may know. Here are some well-known traditional OLAP tools. For example, Microsoft SSAS, Oracle Essbase, IBM Cognos, and MicroStrategy Intelligence Services. They're all good. So far, everything looks good, right? Yes, OLAP is a data analysis solution that has been around for many years and has been proven very useful. But with the advent of the era of big data, it encountered many new challenges. Traditional OLAP works well on small data set, but when dealing with huge amount of data, its performance dropped sharply. Traditional OLAP technology uses a single machine processing method. Cubes are built and stored in a single machine. No processing, so processing performance and storage capacity will be limited by the machine, depending on the CPU, memory, and the storage it has. At the same time, because the size of the cube is limited, but the business needs are constantly growing. A single cube cannot accommodate all the data required by the business. In order to solve this problem, in traditional OLAP tools, it's often necessary to create a lot of cubes to handle different business separately. Then it brings great difficulties and effort to maintain those cubes. For example, when a certain business changes and a certain columns need to be modified, then we need to analyze all the cubes, find all the cubes that are affected, modify some script, and then refresh the data again. This is very time consuming and labor intensive. In the end, no matter how you optimize and manage cubes, as business grows, it will reach the upper limit that the machine can accommodate in someday. And we can only continue to purchase more expensive machines to hold those cubes. For the same reason, cubes processing and refreshing becomes slow and slow. The entire data processing workflow becomes longer and longer. And it often takes a day or even several days to fully load the data into the cube. It's not just a performance that is limited. Due to the limitation of the processing and the storage capability, we cannot add too many dimensions to the traditional OLAP cube, which also limit our ability to conduct a broader and a deeper analysis of the business. In order to solve the problems that traditional OLAP faces at massive scale, Apache Kylin proposed a new method, modern OLAP, combining traditional OLAP theory with big data technology, so that the classic OLAP method can use the big data technology in solving business intelligence problems. Let's think about how to solve these challenges we mentioned earlier. The root cause of the problem is that traditional OLAP technology uses a single machine to process a cube. So naturally, we sort of spreading the cube across multiple machines for processing. In this way, the limitation of storage capacity no longer exists, and nodes can be expanded horizontally without limitation. In theory, cubes are no longer limited in size and can accommodate any number of dimensions and data. We mentioned earlier that too many cubes will cause maintenance difficulties, which we don't want to see. You may ask, will these split cubes cause the same problem? The answer is no. We can imagine there's a logical cube. These split cubes only exist in physical storage, but logically, they're still a whole and the same cube. So you don't need to maintain many cubes. It's the same cube. This solves the problem of a sharp increase in number of cubes. Okay, so we have a new cube that can be very large, unlimited in capacity, and can accommodate many dimensions. Since this cube may be very, very large, it will cause the processing speed to become very slow in the traditional OLAP tool. In order to improve the processing speed, we not only use the storage capacity of those nodes, but also combine the distributed computed framework to utilize the computing power of those nodes. I believe everyone has thought of it. Hadoop can perfectly meet our requirements for this solution. All right, so this new solution is Apache Kylin. Take a quick look at a history of Apache Kylin. It is first developed by eBay and later contributed to Apache Foundation. After a period of incubation, it successfully graduated to the Apache top-level open source project. Later, the founding team created a company based on Apache Kylin, Kyligence, which is my company, to provide the customer with commercial version and the services of Apache Kylin. Let's introduce some core features of Apache Kylin. Apache Kylin is an extremely fast OLAP engine for big data. The first features I want to mention is it has ultra high performance on large scale data. With OLAP and pre-calculation theory, Apache Kylin can guarantee sub-second query response on billion level data volume. These are real data from the community users. Queries on more than 900 billion rows. 99% of the query latency is less than 1.3 seconds. Since the data is calculated in advance and stored in the cube, when a query occurs, there's no need to scan a large amount of raw data for online calculation, which greatly speed up the query performance. With the principle of using space for less time, it provides extremely high query performance. All right, at the same time, Apache Kylin provides a standard ANSI SQL interface. For data analysts, they don't need to learn a new technology, and they can use the most familiar tools to perform their data analysis on large data set. In addition, Apache Kylin also provides JDBC, ODBC, and RESTful API. Analysis applications or BI tools can easily connect it to Apache Kylin. And again, Apache Kylin uses the Hadoop technology stack to achieve horizontally expanded computing and storage capabilities, and are able to meet the storage and the processing needs of massive data. As an OLAP engine, Apache Kylin provides an easy-to-use modeling method that can support multi-dimensional data modeling. It also provides rich optimization and pruning functions so that a single cube can accommodate more dimensions and more data. The user does not need to write code, and they only need to perform multi-dimensional modeling as user to analyze the data, which greatly reduce the maintenance cost of the cube. All right, and then let's take a look at the architecture of Apache Kylin. Here we will not go into the details and the principles of each component. It's just an introduction to help you understand the various components and technology used by Apache Kylin. First, let's take a look from the left to right. On the left side, there are Apache Hive and Apache Kafka. Those two are the supported data stores in Apache Kylin. At present, Apache Kylin can also support RDBMS data such as MySQL, SQL Server, and so on. They are connected with Apache Kylin through JDBC. And then you can create models and cubes in Apache Kylin, which will automatically MapReduce, and Spark jobs based on the defined cubes. These jobs will load data from data source and build cubes. The constructed cube will be stored in HBase on the right side. Using HBase distributed query capabilities, the data in the cube can be retrieved quickly. Just for your information, we are going to replace HBase with a Parquet format in the next release to have better performance and reduce the maintenance cost of HBase cluster. As we mentioned earlier, Apache Kylin provides ANSI SQL interface, and it can also provide query services to applications through JDBC, ODBC, and RESTful. All right, Earlier, we talked about many times, Apache Kylin can provide ultra-high query performance. So here we have a benchmark result. Just want to give everyone a simple impression. This benchmark was performed on the SSB dataset using Kylin and Hive for comparison tests. The figure on the left shows the response time of each query. You can see that Kylin performs significantly better compared to Hive. On the right side, it shows that as the amount of data increase, query response of Hive will also increase significantly. The query response of Kylin will not be affected by the increase in data volume. Let's take a brief look at the users of Apache Kylin right now. So far, more than 1,000 companies worldwide are using Apache Kylin. They are located in various industries, including internet, finance, manufacturing, retail, etc. If your company is also using Apache Kylin, you are very welcome to share your use cases and experience in the community and help others to better use Apache Kylin. All right, time to show a demo. In this demo, I want to give you a quick impression how to connect your data source, create a model and a cube, run some queries against Kylin cubes. It's pretty simple and easy. All right, let's get started with this demo. First of all, we need to connect it to the data source. In this demo, I'm going to use the Hive data source. By clicking the model and choose data source, you can load all the tables from Hive directly. Those are the tables we have in the Hive. You can choose any tables you want to add it to the model. By clicking the sync button, all the tables will be added to the Kylin automatically. And then you can choose all the columns in these tables to the model. After that, we can go ahead to create a model. By clicking the new model button, you can create a model. I'm going to use the existing model I prepared and show you how it looks like in this model. All right, first of all, you need to give the model a name, and then you need to define the join relationship between these tables. Just like what you did in relational database, choose a fact table and join with the lookup table. Set up the join condition, the primary key and the foreign key, and then you can add it to the model. After define all the join condition and define the table relationship, you will get a star schema or snowflake. That is a model. After that, you can choose the columns as dimensions from those tables. Apache Kylin provide a UI. You can just use the drop-down list to choose all the columns you want to add as dimensions. And then we can go ahead to the measures. The same as dimensions, you can just use the drop-down list to choose all the columns you want to make it as measures. All right, after defining the dimensions and the measures, you can go ahead to the last step. In this step, we need to define the partition columns. What is a partition column? Partition column is used to control the data range you want to load to the cube. Sometimes users, they don't want to load data to the cube at the same times. They want to control how the data should be loaded. For example, the common scenarios, we load data by daily, weekly, or monthly. And then you can use these columns to control the data range. All right, after setting all of these configurations, we can save this model. All right, we already have a model, and then we can create a cube in this model. By clicking the new cube button, we can create a new cube. Let's see an existing cube, how it looks like. All right, first of all, you need to choose which model should we use to create this cube, and then give the cube a name. After that, we can choose the dimensions in this cube. Maybe you will ask why we need to choose the dimensions and measure again, since we already do that in the model. That's because you can create more than one model, one cube in a model. You can assign the dimensions in the model to different cubes based on your business scenarios. By clicking the checkbox in front of the columns, you can add it to the cube. All right. After defining all the dimensions, we can go ahead to define the measures. Apache Kylin provide a lot of functions you can use to define the measures. For example, here we have a measure defined with the top n functions. In this measures, we are going to know the top 100 sellers based on their total sales amount in the last year. And then we'll show the seller ID in this measure. Just like this, you can define more dimensions and measures as your business needs. After defining the measures, we can go ahead to another step. In this step, we don't need to set too much, just leave it at the default value. All right, in the advanced setting page, there are a lot of settings you can use to optimize the cubes and pruning the cubes to get a better performance and less building time. I'm not going to deep into the optimization today. We can leave it for further discussion. All right, in the next step, there are some Kylin properties you can set in this page to override the global settings. These configurations will only take effect in the cube level, so it won't affect other cubes. All right, after save these cubes, we can go ahead to load data to this cube. By clicking the build button, you can choose the data range you want to load data. If you remember the partition columns we introduced in the model design, this is how we use the partition columns. And you can choose the data range you want to load. By clicking the submit, it will generate a new job to load the data. And this job is created automatically. It will generate the MapReduce code automatically based on the cube you designed to fetch the data, processing the data, and build the cube. After this job finished, you can go ahead to run some queries against the cube. Here I prepared a cube which is already built. And let's run some queries against this cube. All right, let's run this query. In this query, I want to know the total sales of books by month and category. Let's try to run it. Okay, you can see this query returns in 0.1 second. Because this demo system, we don't have too large data volume. It's a quite small environment. But you will have the same query performance if you using even larger data volume, for example, the billions of rows or trillions of rows. And you can see this queries as answered by the cube, which is we prepared before. You can see the cube's name here. Yeah, let's run one more query. In this query, we want to know the top 5 sellers in the year of 2012, and we are going to use the top n measures we introduced in the cube design. Let's try to run this. All right, this query returned in 0.1 second. And you can see this query is answered by the cube as well. All right, that's all about the demo. Let's do a summary. So you only need to do 4 steps to build your first Apache Kylin cube. First, you need to connect to the datasets, and then create a model and cube just like what I did, and build a cube, load the data to the cube, and process the cube. After job finished, you can go and run some queries against the cube. Here is a link you can use as a reference. We have a step-by-step guide how to build your first Apache Kylin cube. And we also provide multiple ways to deploy the environment. The easiest way to deploy Apache Kylin environment is using the Docker image. It's quite simple. It just took like 3 or 5 minutes. You can get your first Apache Kylin environment. All right. At last, I'm going to briefly introduce some roadmap of Apache Kylin. There are the most important features that a community have planned in the future. First one is fully on Spark. Fully use Spark to replace MapReduce and improve the performance of Qbuild. The next one is, we mentioned this earlier, use Parquet storage to replace HBase, reduce the maintenance cost of HBase cluster, improve performance in multi-column query scenarios. And by replacing HBase, we can have better adapt to the future cloud architecture, which is separating the computing and the storage architecture. And then the next one is Dockerize. We are going to use the Docker to distribute and deploy the Apache Kylin. As I mentioned before, we already have a simple version available for everyone to use. You can just pull the image from the Doc Hub. And then the Kubernetes integration. We are going to support a Kubernetes deployment. Use Kubernetes to deploy and manage clusters. In the future, you will not rely on Hadoop cluster again. And in the cloud, you can use the Kubernetes to manage the resources and store the data in the cloud storage. So the infrastructure will quite simple. And cloud ready, able to support mainstream public cloud platform and integrate with various services on the cloud. All right, the last one is from OLAP to data warehouse. We are going to expand from the OLAP field to the data warehouse field, helping users better solve big data analysis problems. I hope this sharing can help you better understand Apache Kylin and OLAP. If you are interested in Apache Kylin and want to learn more about Apache Kylin, welcome to join the Apache Kylin community and help more people with big data and technology and help build a better open source project and open source community. Here are some ways to join the community. You can fork our project in GitHub. And you can also subscribe our mail group. The mail group email address is here. And you are very welcome to join our Slack channel. All right, that's all the content for today's webinar. Thank you. Thank you very much for today's webinar. Tyler, give it back to you.
Great, thank you, Kaiga. Now I'd like to open the floor to questions. Remember, you can submit your questions via the Q&A button at the bottom of the webinar interface. So let's see what we have right now. We've actually got lots of questions, so it's great that we've got some time. And so we'll try to get to everybody's today. So the first question, Kaiga, that I have is it possible to download a sandbox copy of Apache Kylin so people can test their own large data sets?
Yes, of course. Actually, we provide a lot of different way to try their sandbox. The easiest way I mentioned in the webinar is you can use the doc image, which contains the HTTP sandbox in the image and Apache Kylin distribution package in the image. So you don't need to download any other component, just the image and the launch Docker container. You will have a fully installed environment for Apache Kylin. Another way, if you don't want to use the Docker image, you can prepare a HTTP sandbox, and you can install the Apache Kylin package in the sandbox manually, so that you can experience the whole process of the installation. Otherwise, if you have a cluster, Hadoop cluster on premise on the cloud, you can also deploy Apache Kylin on your cluster, existing cluster as well.
Great. And then, you know, there are other OLAP approaches out there, other solutions that leverage OLAP. Can you maybe expand on the differences that Kyligence and Apache Kylin may have compared to other OLAP approaches on the market today?
Yeah, sure. So first of all, let's compare the open source version with the commercial version. With the Apache Kylin, you can have the basic OLAP functions in big data. For example, what we introduced before in the presentation. But the open source version lack of some enterprise features. For example, if you want to do the access control, or if you want to integrate it with the BI tools in the security level, we don't provide that features right now. And for example, in the commercial version, we already have the packet storage to replace HBase other kube storage, and we have a better performance for the kube for the query. This is the first one, and then in the commercial environment, commercial version, we can fully support the Spark cluster without Hadoop dependency, as we mentioned in the roadmap in the Apache Kylin, right? But it's already implemented in the commercial version. And another thing is we can support, for example, if the data is not loaded to the kube, and we can also support the query. We call it push down query. In the commercial version, you don't need to load all the data to the model and the kube. It can be also answered by the push down, which will make your query more flexible. And after that, commercial version will use the push down query history and together with the AI engine to learn your query patterns and accelerate those queries. The models in commercial version can self-learn and self-train. It will become faster and faster. Yeah, just some difference between the open source and the commercial version. There are a lot of difference. If you are interested, you can visit our website, either the Apache Kylin website or our company's website for more information. Comparing to other OLAP tools in their market, for example, usually some people, they will ask the comparison between Apache Kylin and the Druid, right? I just talk about some simple points between the Apache Kylin and Druid. Actually, Druid is more suitable for the real-time analysis. Although Apache Kylin in the new release, we can support real-time, but Druid is really good at the real-time scenarios. But it's not good at the, for example, the historical data query, because it's designed for the real-time, and it doesn't have better performance when you have a lot of historical data. It doesn't have a lot of aggregation functions. And another point between the Druid and Apache Kylin is the SQL interface. Apache Kylin can support SQL interface, so the analysis, they don't need to write code, and they are very familiar with SQL, right? But for Druid, you have to use another query language and put it in JSON and to run the query. That's a different part for the Druid and Apache Kylin. There are also some other different, but I think these are the most important difference between Apache Kylin and the Druid. Yeah.
Great. Well, thank you for that that very in-depth response. Here's another good question that we received. So Power BI has a limitation to upload data sets into PBI Cloud. How does Apache Kylin work with Power BI? Is it necessary to use SQL analysis services, for example, to work with large amounts of data, even if someone's using Apache Kylin to provide their data?
Oh, no, it's not necessary. Actually, we provided a ODBC driver, and you can use the driver to connect it with Power BI directly. But currently in the open source version, we can only support the import mode, which means the data will be loaded to the Power BI, and then you can create a report in the data. It's pretty much like the other data source. In the commercial version, we have a commercial ODBC driver, and you can use that ODBC driver to use another connection way, which is a direct mode. The limitation of an import mode is all the data will be loaded to Power BI, the memory of the Power BI server, or Power BI desktop. So it's limited by the memory of the machine. When dealing with a lot of data volumes, you cannot load all the data to the memory, right? So that's why we support a direct mode in commercial version. By using the direct mode, you can you don't need to load all data in advance to the memory. And all the queries will be sent directly to the data source, and only the result data set will be fetched back to the Power BI. So this significantly reduce the data loaded to the Power BI, and you can handle a lot of data in the data source.
Thank you. What is the most stable version of AWS EMR and Apache Kylin that supports AWS Glue as metadata?
Yeah, that's a good question. Actually, there are some Jira right now in the community, and we have a patch you can apply to support AWS Glue as a metadata. But right now, I think it haven't been merged to the main branch. I need to confirm this information. But as I remember, it hasn't been merged to any release now. There are some ways to connect it, AWS Glue as a metadata, as a data source. You can use the beeline to connect to the Glue, and it will work around the library missing issue. Another way is you can apply the patch in I think it's in another branch. For more information, you can go to the GitHub and other Jira to search for the related issue. Yeah, I will confirm with the community if we already have this function released, but I remember it hasn't been released.
Great, thank you. Is it possible to run queries in Presto and Impala too?
Yeah. So as I mentioned before, for the Apache Kylin, we also support push-down functions. There are two ways to connect it with, for example, Impala or Presto. It's very interesting to combine the Apache Kylin with MPP search engine. We are not a competitor. Actually, we can combine together to serve better scenarios. The advanced MPP search engine, actually, they are very flexible. They can support all of the query scenarios, no matter the dimensions or the measure defined in the model or not, right? But the advance of Apache Kylin is good at the query performance. It will have a better performance if you build the cube and predefine the model. So it's kind of, for example, the report scenario, it will be suitable for using Apache Kylin. But if you combine the Presto and the Impala together with Apache Kylin, you can serve not only the OLAP scenarios, but also other discovery queries or flexible queries. How to combine this together? The first way is you can use the Presto as the data source. With the JDBC data source connector, you can load data from the Presto and the Impala to our Apache Kylin cube. And then you can push down those queries, which is not designed in the model, back to the Presto and Impala. That's combined the two different technology together to have serve better business scenarios.
Great, great. And then the next question that we have, and we've actually got many questions that are coming in right now. So Kaigo, if you could try to keep things maybe a little bit short, and if people need to follow up, they can obviously reach out to the community, they can reach out to us.
Yeah, sure.
And for those that are asking questions about the Q&A section, we can actually see it from our side. So don't worry, if you're not seeing anything in the Q&A boxes when you submit, we can actually see them. So we've got all of your questions, believe me, and we're gonna work on getting to as many of them as we can. All right, so the next one that I have is someone had missed the answer to this question. I believe you already answered it though, but you know, what is HBase being replaced with in the future version?
It's already in the roadmap, and as I know, we already have a prototype for this version. You can check the Apache the storage on Parquet V2. This is the latest branch in the GitHub. And I remember just maybe yesterday or the day before yesterday, they released the latest function test. You can have a try. For the official release, maybe I'm not sure. Maybe the next release. Yeah, you can keep an eye on the community release announcement.
Great, great. And so could you also clarify that the only way to actually use Kylin, do you actually need to be running it on Hadoop?
Yeah, the short answer for this question is yes right now. Currently, we are still depends on Hadoop. To run Apache Kylin, you have to have a Hadoop cluster or Hadoop environment. But as I mentioned in the roadmap, we are going to switch MapReduce to Spark, and we can use Kubernetes to manage the Spark cluster, which is a Spark on Kubernetes. And then after we replace HBase with Parquet, all the storage can be in the, for example, the S3 or the Air Blob storage or Data Lake cloud storage. So in the future, on the cloud, you can deploy the Apache Kylin without Hadoop dependency.
Great. And is Kylin supported to Cloudera Data Platform?
Yeah, of course.
So can you share MDX queries on the cube corresponding to SQL that you're demoing, or how robust is MDX support with Kylin or Kyligence even?
Yeah, that's a good question. Actually, maybe there's a misunderstanding about the MDX. For Apache Kylin, we cannot support MDX language. We only support ANSI SQL interface. So if you want to run some multi-dimensional query, you have to use the SQL instead of MDX. You need to translate MDX expression to SQL queries. But in the commercial version, we have a product called Kyligence MDX, which can support MDX, and it will translate the MDX expression to SQL directly to the cube and answered by the cube.
Awesome. And can you write a query to join or combine data across multiple cubes?
Yeah. For the query combined together, the query answered by different cubes, there's a way we call it a hybrid cube. You can use that way to combine different cubes together to answer such kind of a query. But I don't have an example on hand. So if you have any interest, we can discuss it in the community. Great.
And then is the cube storing pre-computed calculations or aggregations?
Sorry?
The cube storing, it's all pre-computed calculations and or aggregations?
Cube storage, you mean?
Yeah.
Yeah. Currently, all the cubes pre-calculated are stored in the HBase as H file.
Okay, great. And then what happens if there's some kind of error in when a node's processing?
Sorry, what was that, the question, the error?
Yeah, how does Kylin behave if there's some kind of error in the node's processing?
Okay, so if the nodes have some error when processing the cube, because Kylin depends on the Hadoop cluster, so the stability of the nodes depends on the Hadoop cluster. So Kylin only store the metadata of the job or the cube. So if something went wrong, the metadata will be saved safely, and the job can be restarted when the Hadoop cluster is recovered.
Great. What version of Kylin were you demoing today?
I'm using the version 3.0.1, the latest version.
Do you have any quick examples that come to mind about Kylin's application when it comes to running, predictive analytics?
Yeah, let me see. That's a good question. I don't have an example in my mind right now. There's too many questions. Yeah, we can discuss this in the community.
Okay, great. Is there a console with history with the history of queries with Kylin?
The query history will not be saved by Kylin, but you can save some queries to their metadata in the UI, actually in the inside UI page, if you want.
Do you know when exactly Spark support's going to be available?
That's a good question. It hasn't. It doesn't have a exact timeline for the Spark support. Uh, but as you know, we already have a Spark engine for the cube building, which can be used instead of the MapReduce. Another things we need to replace, wholly replace MapReduce is for example, the data source part. We need to use Spark to load the data from Hive or from other data source. This part won't be too complex. I think it can be finished super soon, but we don't have a exactly timeline right now.
Great. And here's actually an interesting question. What's the largest cube size, with Kylin you might be aware of, or even with Kyligence that you're aware of, that that a customer or someone using one of these solutions has built, and if you know maybe how many CPUs were used to support that cube?
Yeah, that's a good question. As I remembered, for the Apache Kylin, there's a use case shared by the Meituan, which is the top one O2O company. I can't remember the exactly number of the size of the cube, but I remember this use case is shared in the Apache Kylin website. You can find this by searching the use case or by searching the Meituan. That there is a exactly number in that blog.
Great, thank you. We got a few more minutes, so we'll try and get to as many more of these questions as we can. If we can't get to your question today, you can always reach out to us, and we're more than happy to follow up with you and get you an answer to whatever questions you may have or that may have come up while listening to this presentation. Here's another one that we have though: is aggregated data stored on file in HDFS?
Yeah, actually, it started as a H file, which is a file format for HBase. And as you know, HBase stored the file in HDFS. If you run the environment on cloud, you can save the file on the cloud storage, for example, S3 or Azure Data Lake, which are also supported.
Great. And Apache Kylin, it supports ANSI SQL?
Yes, Apache Kylin can support most of the functions in ANSI SQL.
Okay, great. Where is the best place you'd recommend? Plenty of people on this webinar have certainly already tried Kylin, but when it comes to debugging, obviously it can be a challenge as an open source solution to find some of the stuff. But where would you recommend folks go when it comes to getting the right documentation or help to troubleshoot their issues with Kylin?
Yeah, this is a very good question. For debugging the Apache Kylin code, because currently we need, depends on the Hadoop environment, I will suggest you deploy the sandbox in your computer, and you can use that environment to debug Apache Kylin. And how to set up the development environment, there's a document in the Apache Kylin site. It have a step-by-step instruction how to set up the environment. And if you have some issues with the setup environment or with the debugging the issues in Apache Kylin, you can always go to the mail group, go to the community, and a lot of experts there, they can help you on those issues.
Awesome. And when it comes to Apache Kylin, are there limitations around the number of measures that can be leveraged?
Yes, so physically, the limitation of the measures, the number is 63. It's hard limit. So, but we have another way to go up the limit. We define the dimensions as the derived dimensions. It will not be counted as the normal dimensions, so it can above the 63 dimensions. But usually we won't recommend too many dimensions in a same cube. For example, if you have more than 30 dimensions in the same cube, the query performance or the building time will be super long. And in this case, we will suggest to use a lot of optimization ways in Apache Kylin to optimize your cube.
Great. And what data sources can Kylin support?
Right now, we can support Apache Hive and Apache Kafka as their real-time solution. And we can also support a lot of RDBMS, for example, the MySQL, SQL Server, yeah, such kind of relational database.
Awesome. A couple more questions I think we'll be able to touch on, but one of the unique problems with OLAP is distinct count measures, and they cannot be pre-aggregated. How is the performance of these measures for data volumes, over a terabyte?
I don't have an exact testing number of this kind of query. Yeah, so talking about OLAP in scenarios, the measures has to be pre-calculated, right? If the measure can be pre-calculated, their performance will be very good because their performance won't be affected by the data volume. Even you have a lot of tons of data volume, it won't be affected. But if the measure cannot be pre-calculated, it will go to the on-the-fly calculation. That will significantly affect the query performance. It depends on the query scenarios, how complexity of the query and how complexity of the measure, it depends.
Okay, great. And can you also reiterate, what's the most stable version of Kylin to use this time on EMR?
I will suggest Apache Kylin 2.6. That's because I tried that before. I'm not sure because there's no official testing report about their on the AWS EMR, but they do have a lot of use cases in the community. Yeah, I can share some information after this webinar. I can go ahead to their community and summarize those information.
Okay, great. And then obviously, we're reaching the top of the hour here. Could you just maybe go back a slide to show people the contact information? But if people have further questions that they didn't feel like we touched on or sufficiently answered today, it's possible. Obviously, they can reach out to these areas of the community. But it's also okay if maybe they follow up with you as well.
Yeah, sure.
All right, wonderful. All right, so that's going to be it for that right now. Well, that's all really the time we have for today. We apologize if we didn't get to all of the questions. There certainly was a lot of them, but we're more than happy to follow up with each and every one of you if there was something that you just didn't get a sufficient answer to today. We're more than happy to work with you about that. But thank you again, Kygo, for sharing your insights with us. And an extra special thank you to everyone who attended today's session. We hope you got a lot out of it, and we look forward to having you at our webinar next week, Thursday, April 16th, that has us looking at how the OLAP approach we discussed today can be applied to BI tools like Tableau to dramatically accelerate analytics performance. To get started with Apache Kylin, you can visit kylin.apache.org. And if you're interested in learning more about Kyligence and our enterprise-ready solution for analytics acceleration, or just like to set up a personalized one-on-one demo, visit our website at www.kyligence.io. And if you're wondering about the free Kyligence shirt, keep an eye on your inbox for an email from a member of our team with more information on how to request that. And as for the $100 gift card, we'll be holding our drawing later this week, and we'll reach out to you if you've been selected. Also, be sure to follow us on Twitter at @Apache Kylin, all one word, and @Kyligence, as well as LinkedIn. Thanks again for attending. Have a wonderful rest of your day.